This is the recorded PowerPoint for Chapter 2. They call it Lesson 2. There will be two recorded PowerPoints for this chapter. Chapter 2 is the Internet of Things and how it's changing the way we live. The learning objectives to explain information system security and its effect on people and businesses. The key concepts involved. We're going to talk about the evolution of the Internet of Things, or IoT, from the late 1990s to the present. The impact that the Internet and IoT have had on human and business life. How bricks and mortar businesses transform into e-business models with e-commerce and an IoT strategy. How IP mobility is driving IoT to include both personal and business environments, and new challenges created by the IoT. So here we see how it is changing the way we live. Obviously, in social media, there are all sorts of different uh, applications in it. Facebook, Twitter, LinkedIn, Pinterest, Google Plus, Instagram, you name it. And the mediums that we do it by: voice over internet protocol, or VoIP, internet messaging chat, audio conferences, video conferences, various different ways of collaboration, digital media. In fact, when it comes to audio video conferences here at Georgia Southern, with both campuses being 50 miles apart, we use uh, WebEx for audio video conferencing because there is a tremendous need to be able to meet um, without having to drive either from Statesboro to Savannah or Savannah to Statesboro. So the drivers of the Internet of Things. First one is IP-based networking, and that has been globally adopted. The Internet provides global connectivity for any user, business, or device. Connectivity is everywhere. Broadband internet connectivity is provided free in many public areas and is a benefit for customers, such as in hotels, restaurants, and airports in cities globally. Smaller and faster computing. Smaller semiconductors and faster chips results in faster computing and smaller device sizes like our smartphones. Cloud computing is growing. Cloud services allow for faster and easier access to data and content. And data analytics feeds this growth, capturing and studying the analytics of what, how, when, and why devices connect and communicate on the internet, feed analytics for enhancing service and performance. When we look at the evolution of IoT, we first start with internet service providers. The IoT provides an avenue for things to connect. It has evolved from those internet service providers, allowing us to connect to the internet, all the way to radio frequency ID chips, RFID chips, allowing us to connect. Application service providers are software companies that build applications hosted in the cloud and on the internet. Users don't have to buy software and install it on their workstations. Rather, they run the applications hosted in a cloud using a secure browser. This is sometimes called software as a service, or SaaS. With the growth in cloud computing and cloud hosting companies such as Amazon Web Services, or AWS, came the growth in cloud application development. IoT applications for both personal and business scenarios were born, with application service providers building software as a service applications. New online e-businesses were born, and today you must have a storefront, pardon me, a storefront on the World Wide Web. The transition to a transmission control protocol, Internet Protocol, TCP/IP world has changed our lives. People, families, businesses, educators, and government all communicate differently than they did before. The internet has changed our day-to-day lives personally, socially, and professionally. We use the internet to check weather. As a matter of fact, as I'm recording this, I just looked at the latest track of what is now Hurricane Dorian, and it looks like it has moved slightly to the south and going to go straight across. the state of Florida, going through somewhere near Orlando and coming out the other side near Tampa. So we check the weather frequently with it. We check news, social media sites, and business emails at work. People use the internet to do fantasy football, fantasy baseball. So the internet has impacted the way we do things in our lives. Now we have to talk about store and forward versus real-time communications. Real-time occurs instantaneously. Store and forward, though, require or has an acceptable delay in transmitting communication. An example of store and forward, a voicemail can now be converted into audio files and sent to your email inbox. Indeed, we do this for faculty and staff at Georgia Southern. This is an example we call unified messaging, or UM, in which all of your messages, both voice and email, can be accessed by way of email. I do it all the time when I'm at home. I get an email, and the email says that there was a voicemail on my message box, and I go and I listen to it on my computer at home. Some of the things involved in the Internet of Things impact on humans. Sensors can monitor human vital statistics and securely send data analytics to mobile application. How many of you use Fitbit or Apple Watch and record your fitness stats? Of course, I use Fitbit myself, and I record my own stats. Today I have 7,538 steps. But think of this, how many corporations are going to require their employees to transfer such data to them or their insurance provider in order to obtain lower health insurance premiums? What about adversaries tracking U.S. servicemen and women as they run with these devices, recording their GPS in a combat zone such as Afghanistan or even in the Pentagon? By the way, U.S. military policy now prohibits wearing such devices in both locations and any kind of secret location. Home security. Systems such as Ring, which I have on my house, I can monitor whoever comes to my door, even from my office. There was an article in the Washington Post today about how police departments are trying to get people who have Ring to opt into um, using their neighborhood application to, well, I don't want to say spy on potential or alleged or people that could be criminals or may not be criminals. But think about this: Amazon owns Ring, and they have already and they can uh, transfer your data to whoever wants it, presuming you store the data. Um, in any case, home security systems now are definitely part of the Internet of Things. Online family calendars. This could be vital if parents have to drive their kids around from sports practice to music practice to all sorts of other activities. GPS, again, the military personnel not tracking their whereabouts on Fitbit, but other applications. Parents can now track their children by their phones. And of course, we use GPS for maps in our cars. Uh, Indeed, my Fitbit, I don't do it this way, but it would, if I wanted to track walk as opposed to um, just the fact that I'm recording steps, but an actual walk or an actual run, I would have to enable its connection to GPS through my phone and run with my phone in my pocket when I exercise. I really don't like to do that, but I'd have to enable the GPS to in order to record that as a run. Online banking. When was the last time you wrote a check? Have today's students ever written a check? Transactions can now be made from any location. People can now get up to the minute status of their accounts. Online e-commerce purchases. Is there anyone in this class, or maybe any class at Armstrong or on the Armstrong campus or Georgia Southern, that has never done this? Of course, shopping, but also hotel and air reservations, as well as air boarding passes. And that's another thing. How many people actually print their air boarding passes anymore? All of us put them in our app on our phone, and they scan the phone with the QR code and they let you into the airplane. So uh, it has had a tremendous impact on people, but it's had also a very large impact on business. Retail stores, banks, restaurants now must have an online presence. But what's this doing to brick and mortar retail? While there may be other factors involved, just go to Savannah Mall to see how online is one component of its demise. Virtual workplace, businesses and companies that are in the people or professional services businesses do not need to come to a physical office unless it is for important meetings or presentations. Indeed, with all the IT professors at Georgia Southern being in Statesboro except for me, WebEx is the preferred method of meeting. And I actually have at least one of these meetings coming up Friday, and I had one 2 days ago. Remote sensors, monitoring of electricity usage, water usage, pH balance of water, and carbon monoxide meters. Traffic monitoring. Smart cities can monitor and report on real-time traffic flow conditions and perhaps redirect traffic flow or change speed limits. They do it on the expressways in Atlanta. They actually change the speed limits on I-85 and I-75. All of the interstates, 20 and 285, they change the speed limits periodically throughout the day based on traffic flow that their sensors record. B2C service delivery model, new web applications, business to customer, new mobile applications providing online access to their products and services, anything as a service IoT applications. These allow businesses to transform themselves into an IoT service offering. This means that whatever you are currently doing can be transformed into a hosted secure cloud solution where you access your content information from a website. The evolution from bricks and mortar to e-commerce. So e-commerce is, of course, the sale of goods and services on the internet. Business to consumer is, or B2C, is the customers who purchase goods and services directly from their website. Business to business, or B2B, is businesses conduct sales with other businesses. And the payment card industry data security standard, PCI DSS, protects private customer data. Going along, continuing on with the evolution from bricks and mortar to e-commerce, we have some internet business challenges. Growing the business through the internet, changing an existing conventional business into an e-business, building secure and highly available websites and e-commerce portals, building a web-enabled customer service strategy, and finding new customers with internet marketing. So some e-business strategy elements, which talk about e-commerce solution, might be an online cataloging system for purchasing goods and services in a secure transaction. Internet marketing strategy. These involve search engine optimization, or SEO, which uses embedded meta tags and keywords to help search engines sort results and create customer lead generation. E-customer service delivery strategy. Self-serve and online customer service strategy is what this could be. Payment and credit card transaction processing. Secure online payment processing and credit card transaction processing must be encrypted with strict back-end system security controls to prevent the unauthorized access to private data. Why businesses must have an internet and IoT marketing strategy? They have to remain competitive. Bricks and mortar the business model is out of date in a global market. Customers require continuous access to information, products, and services. But the internet presence exposes organizations to online risks, threats, and vulnerabilities. Here is a slide right from our textbook, Transforming an E-Business Model on the Web. So obviously, you go from customer acquisition and revenue growth, the emails for business communications and an informational only website, and a bricks and mortar business model with no internet strategy, to the e-commerce and enhanced customer service, where you have unified communications, voice, fax, and email, secure online business to customer shopping and purchases, customer service oriented website with FAQs, email, and contact number, and internet marketing where email blast, search engine optimization, and pay-per-click. So that's phase 2. And then when you get to phase 3 is the e-business with integrated applications. Here you have the enhanced customer service website with unified communications, lead generation-based website for sales, secure e-commerce for B2B transactions, and complete business strategy linking internet marketing, enhanced customer service, and e-commerce. IP mobility. So personal communication devices like our smartphones are powerful, and cell phones or smartphones are used to extend the mobility. It says here, and PDAs, nobody uses really a PDA anymore, but but the smartphones match the power and flexibility of small computers. And we know this, our iPhones and our Samsung devices might as well be a computer. We can do so much with them. We can even make a presentation from PowerPoint um, or the Google version of that at a meeting right off our phone. Tablets, smartphones, and netbooks fill the need for lightweight portable devices. I take a lot of notes on my smartphone when I go to meetings. Um, it's a small screen, but I'm able to do it. Mobile users and bring your own device, or BYOD. So employees and contractors use their own personal devices in BYOD to connect at the office, but there are issues with this. Network. Will the device be interoperable on our network? Will it work on our network? Usability. Will the device's applications be able to be used on our network? It's not enough that the device will work, but what about the applications? Will our network impose too many restrictions, perhaps even security restrictions or bandwidth restrictions on our users and the applications on their smartphones? Security. Will users adhere to our security policies while using their devices on our network? Will users be required to download and install security software that we require? If we require this, will users even do it? And there are a host of other security issues. 2G, 3G, and 4G. So 2G was the analog devices using circuit switching, no packets were sent. This is obsolete. 3G came into being around 2000, 2001, cellular packet switched and circuit switched hybrid, faster data transfer speed than 2G, minimum of 144 kilobits per second. 4G was totally packet switched, peak speed requirements at 100 megabits per second and 1 gigabit per second for low mobility communication. You're not moving around a lot. And 5G is here, but networks have to be upgraded and you have to have a 5G device to get the full benefits. It will use millimeter waves. New 5G devices have 4G LTE capability as the networks aren't ready for 5G just yet. 5G supports 1 million devices per square kilometer, which is a lot, while 4G only supports 100,000 devices per square kilometer. The International Telecommunications Union's initial standard required theoretical peak download speed of 20 gigabits per second and 10 gigabits per second upload speed. Another feature of 5G is the improved shorter latency of signal, also known as delay, than in 4G. Mobile applications, of course, limited web browsers can't run some traditional applications, but I'm able to find in my Google Chrome on my smartphone, it's able to run a lot of different applications. Or websites at least. Bad interface design caused application failure on mobile devices, but that has improved incredibly. Many users from multiple domains found uses for mobile applications, and medical applications were a good fit for mobile applications. You can understand this textbook was written in 2014, um, and that was the upgrade for the IoT. I'm sorry, the original textbook was written in 2014. This is the 2018 version. Nonetheless, um, what's happened in IoT is incredible because now so many of our smartphones are able to do so many different things and run so many different applications than they weren't able to run before. 4G networks provide true IP communications, and mobile IP enables users to move between LAN segments and stay connected without interruption, and maintain a connection to the network as long as the mobile device stays within network coverage. Okay, so this is talks about things you have to have in IP mobile communications: a mobile node, a home agent, a foreign agent, a care of address, COA, and a correspondent node. We'll go over each one, and the next slide describes how they work. Mobile IP provides connection transparencies for several entities working together to ensure that mobile devices can move from one network to another without dropping connections. The mobile node, the mobile device that moves from one network to another. The mobile node has a fixed IP address regardless of the current network. The home agent is a router with additional capabilities over standard routers. The home agent keeps track of the mobile networks it manages. When a mobile network leaves the local network, the home agent forwards packets to the mobile network's current network. The foreign agent is a router with additional capabilities connected to another network, not the home agent network. The foreign agent assigns the mobile network a local address. When the mobile network connects to another network, that supports mobile IP. It announces itself to the foreign agent. Care of address, the local address for the mobile network when it connects to another network. The foreign agent assigns the care of address to the mobile network and sends it to the home address when the mobile network connects. In many cases, the care of address is actually the foreign agent address. The home agent forwards any packets for the mobile network to the care of address. The foreign agent receives the packets and forwards them to the mobile network. Correspondent node. This is the node that wants to communicate with the mobile network. So here's how it works. This is our last slide in part one. First, the mobile network connects to the foreign agent. So you see the mobile node down there, and he connects right here to the foreign agent. The foreign agent assigns care of address to the mobile network. So here he goes back that way. The foreign agent sends care of address to the home agent. So he sends the care of address this way. The correspondent node, which is up here, sends the message to the mobile network. So he sends that message all the way down to the mobile network. The correspondent network's message for the mobile network goes first to the home agent. But before he goes down this, he has to go this way to the home agent. The home agent forwards the message to the care of address. The foreign agent forwards the message over here to the mobile node. That is the end of part one.